So for our logs test tomorrow, you need to know what log base 3 of 3 to the negative 1 is equal to. Don't say it, write it. Could be a piece of cake. Now, if you could say it on 3, the answer is on 1, 2, 3. Negative 1, very good. Okay, so if the bases are the same, the answer's already there. Here's another example of the bases the same, the answer's already there, but it's going to trip up a lot of you. 3 to the power of log base 3 of 3 to the negative 1. All right, that changes it. This time the answer is going to be harder to say, and so I would like you to, first of all, if you know the answer, if you really know the answer is not just a simple number like 3. It's not. All right? So figure out how to simplify it all the way down, as simple as you can, and then tell the kid next to you what you think it is. All right, this is one of the most common, hard ones for kids, even though it's easy. If you know these two are the same, then you know that the answer is right there. It just happens to be that whole thing. And what is 3 to the negative 1? It's 1/3. Who knew it was 1/3? Raise your hand if you had 1/3. All right, good job. Because 3 to the negative 1 is 1/3. And you might be like, why can't I just say 3 to the negative 1? Because do you remember that you can't leave negative exponents in your answers? They're considered like not simplified all the way. So that is 1/3. That's the final answer. Okay, remember, if the bases are the same, the answer is already there. All right, how about yesterday? You just learned about E, didn't you? So what if I said log base 4 of E, and I'm going to put a little 2 in front of that. Can you simplify that as much as you can? Now, some people's brains just melt because there's an E. Isn't E just a number? Isn't E just a number? So couldn't I actually ask you for what this is as a decimal? Because that's just a number, and it's basically a big log that could be put in to a calculator. But let's not do that. Let's just give the answer as simple as we can. So that 2, all it can really do is go up there. Who knew that I was talking about that? Okay. If you didn't know that, that's an important thing to remember. The exponent rule, we call it, because it goes up and becomes an exponent. All right, now, if you had to put this in a calculator, do you know how to do it? Why don't you grab your calculator? If you need to borrow one, you should walk up now. Pause for a second. I'll hand you one. If I was going to put this in on the calculator, I would go hit math button, and then alpha, and then the math button. And I would hope that my calculator was the kind that would just pop up with log, with a little box down there and a little box right there. And then I would just, in this box, I would put a 4, of course. And in this box, I would put E squared. And in case you forgot where E is, it's above the divide key. Does that make sense? Get a decimal. Now, wait a minute. What about the kid that doesn't have 2 boxes pop up like this? I want to remind you how that works. Then you would type log E squared. That's just the log button, which means it's base 10. It's kind of weird. You're changing the base. It's true. Over log 4. See, this part goes on the top, and this part goes on the bottom, and they're both separate logs. And that will also work. It'll be equal to this other way. They should come out to the same decimal. Would you please check it with the kid next to you and see if you ended up with the same thing? Did you guys get 1.44-ish? All right, good. Okay, so that crosses an important, border where, not only you have a calculator, but you know how to put in a log that isn't base 10. All right, how about if it's base E, ln of 4? Can you put that in your calculator? Just give me the decimal for it. And you'd think it'd be easy if you understand this. But for some people, they don't know what to do because they're like, oh, it doesn't even have a base. And there's two kinds of kids. There's the kind of kid who understands that there's an ln button, then you can just go ln4 and you're done. And then there's the kind of kid who thinks you have to do this, log base e of 4. And I did say that it would be smart to always change it to log base e of 4, and that's true, but you don't have to type it in that way. Just type ln4, enter. Gavin, what was ln4?
1.38.
Anybody verify that? 1.38? Okay, good. All right. So now let's talk some more about E because it was brand new yesterday. So E to the ln 7. If you do what I told you to do, and I even mentioned it within the last 2 minutes, then this becomes easy. Okay, talk to that kid next to you. What is the answer to this one?
7.
It is 7. And if you're like, why the heck would that be 7? You maybe haven't replaced this with log base E yet. And if the bases are the same, the answer's already there. And it's up there and it's 7. Okay, cool. All right, next thing is ln e to the 4th. And if you get this stuff, you'll have the answer really quick. Okay, can you talk to the kid next to you on that one? All right, now I heard a lot of people say 4. And if you replace this with log base E, you'll see, oh, bases are the same. Answer's right there. Okay. So one of the things that for sure has come up a lot is, can you combine logs? So let's go log base m of 3 minus log base m of x equals log base m of 5. Can you combine those two logs together? And then will you notice that the bases are the same? So the answer's already there. All right. Talk to that kid next to you. What do you think it is? All right. Did you make log base m of 3 over x? This right side I'm just copying. That's easy. But this combined together, and now they have the same bases, so the answer's already there. That has to equal that. 3 over x has to equal 5. Now, some kids still struggle with solving that. I want to just remind you that I taught you how to clear fractions a long time ago. That's what's making this a fraction. So if you times by x on both sides, that'll cancel that, and 3 equals 5x. Now I have to divide by 5 on both sides, and x equals 3/5. If you need a little lesson on that one, come up and ask. Who had 3/5? Raise your hand if you had 3/5. Nice, okay. Next kind. A log base b of c equals p. My question is, can you rewrite this as an exponential? That's another way to say the circle of logs. Now you'd have, if you asked me that on the test, if you were like, what does rewrite this as an exponential mean? I can't tell you. You have to know that this is called a log, and you're supposed to know an exponential is the other thing that's not a log. Now some of you are going to struggle with what to do with that a. If you fix the a, it won't be hard at all. Sadie, back in the back, Sadie. What do you think I should do with the A? Yep, make it an exponent on the C, and then I can do the rewrite. Other Sadie. B to the P equals C to the A. Raise your hand if you had that one right. Awesome. That is an exponential because it doesn't have a log and it has exponents. Okay. Next one. Sometimes we hide the X in the basement. Solve that one. Anytime you're trying to get the X alone, you should be thinking, I'm going to rewrite this thing and see if it makes it better. Rewrite, the big one. It's the main thing. Being able to rewrite this from one form to the other, from log form to exponential and back again. I bet you'll use that more than anything else on the whole test. X to the 2 equals 4. Square root, square root. Did you remember the absolute value and get two answers? Raise your hand if you did. Oh, it's only half of you. Boo. So easy to make that mistake, isn't it? You just did a square root on both sides. Even if you do the little fraction 1/2 on both sides, you know, power of 1/2, that's a root. And if I just look at the yellow writing here, you know there's two answers for that. 2 and -2. It's just going to be really easy to forget that. Now, it's a smart kid trap because you got two answers. And what if you put these two answers and one of them is wrong, isn't it? Look back at it. Now you remembered that there was two answers, but you forgot that one of those answers doesn't work. Did you check for that? Oh, such an easy mistake to make, isn't it? Because, look, this one, when you put it back in right there, you're not allowed to have a negative base. So that guy has a name. It's extraneous. Now, I know some of you are going to be like, well, I already had it right because I just had 2 for the answer. No, you forgot that there were 2 answers and that one of them doesn't work. You can't just like ignore this other answer. You got to identify that it's there. Remember that there is 2 answers and then go back and check and make sure that they both work. And that one doesn't. All right. And if you're questioning if does 2 actually work, because you're saying it works, Mr. Server, watch. I can check it. I put a 2 here. 2 to the second equals 4, doesn't it? So I know that worked. I know the answer's 2. Okay. So let's see. What else should we practice? Oh, graphing. Let's make sure you can graph. Y equals 3 log base 2 of x minus 3. I want to do the whole deal, which is find the dots, the 3 points, and actually graph it with the asymptote in there. So it'll tell you, don't forget the asymptote, because people forget it all the time. The other thing is they'll make an asymptote with a solid line. That doesn't work. Asymptotes have to be dotted lines. If we didn't have the test on Friday, we would be celebrating Pi Day on Friday, but Pi Day is technically Saturday, so we're going to celebrate it on Monday. Just a little reminder. Have some bragging rights. My daughter still is proud of the fact that she won in 5th grade. Of course, she had to actually work pretty hard at it. She had to memorize 100 digits of pi. She had heard ahead of time that the teacher gives a pi in her 5th grade class to anybody who could memorize 100 digits of pi. So she did. 100, I would be incredibly impressed. But All I've said that I really think you should go for is 23 digits of pi, because I've got it memorized that far, and it isn't that bad if you memorize them in little sets. 3.14, 159, 26, 535, 8979, 323, 84, 626. That's my little, how I clumped it together. You can clump it any way you want to, but if you clump them in little sets of 2 or 3, it's actually more like memorizing 1, 2, 3, 4, 5, 6, 7 numbers, because there's, after the 3.14 that everybody already knows, there's just 7 little clumps. If you can memorize 23 digits of it by Monday, putting your name in the hat for a pi, if you're the best in the room, if you can go further than that, and you get, maybe you should just memorize 2 more after that, and you might be the best in the room. I'm sure a few people will memorize it to the 23 digits that I know. But if you're the best in the room, you will get a slice of pie. I've changed that from what I first told you, which was just you get your name in the hat. People that have the best in the room, the number 1 kid in this hour, will get a slice of pie. All right, and I probably will bring that on Tuesday because I'll let you pick, because I don't want to give you a slice of pie and maybe you don't like French silk or whatever. So, all right, plus you get some bragging rights. All right, here we go. I hope you knew that 3 would give you the asymptote. You don't have to do it that way. You can also do it this way. I noticed that the asymptote would have been at 0, but it moves right 3. So you can go like this and know your asymptote would be there. 2 ways to get the asymptote. Okay, next, I'd try 4. And I'm not guaranteeing it works, but I'd try it, because I know it's close to 3, which was where the asymptote was. So I try it, and then 4 minus 3 is 1. Ooh, I won the argument. If there's a 1 in the argument spot here, then the whole thing is 0, and 0 times the 3 here in front is still 0. 4, 0. Raise your hand if you had 4, 0. Awesome. And then that's right about here. And then I'd try 5. Putting in a 5 here. 5 minus 3 is 2. Log base 2 of 2 is 1. 1 times the 3 is 3, so 5, 3. And I think 6 is just not going to work so good, because 6 minus 3 would be 3, and log base 2 of 3, I don't know what that is. So then I go to 7. And 7 minus 3 is 4. Log base 2 of 4 is 2. 2 times 3 is 6. 7, 6. And your log generally looks like that. It's got 3 distinct points. And 1, 2, 3, and the asymptote. And there you go. Yes?
Could we also do 3 and 1/2?
I love it. You remembered the fraction one. 3 and 1/2 is a great one, because then when you subtract off the 3, you'll have a 1/2. And log base 2 of 1/2 is -1, so then it would be -3. I agree. So 3.5 comma -3. And that would be like down there. So as long as you have 3 points, don't have to have that point, but it's a good one to know, because sometimes it's going to go off the graph unless you can do the fraction kind. So I'm glad you brought that up. Okay. What else do you have to know? A lot of things. But one of the things that we've practiced multiple times is quadratics. So let's just say that you had to solve this. X plus 2 times x plus 3 is equal to 4. Now you might be thinking, oh, the answers are -2 and -3. No, they're not. So what are you going to do? With quadratics, before you try to factor them, you've got to do something, and I hope you remember what. This is the part where you write this one down, and then you talk to the kid next to you about strategy. And it might, if you can't factor it, involve a big honking formula. You know we've been practicing quadratics again. I did tell you that the most important function, and I told you that factoring was the most important skill of the entire year. So it might just factor if you're lucky. So if you can factor, you should. But if it doesn't factor, you gotta have a backup plan. All right, what you should do, it doesn't actually matter whether you multiply this all out first and then subtract 4, or if you subtract 4 right away. But you got to set it equal to 0, and the easy way is to get this 4 out of here, so you subtract 4 at some point. I'm going to multiply this out first. X squared plus 3x plus 2x plus 6 equals 4. And then I'm going to go x squared plus 5x. And then I'm going to subtract the 4 from both sides. And 6 minus 4 is 2 equals 0. And then if you can factor it, you should, but you can't factor it. So now what? Talk to the kid next to you. You know that big honking formula. Actually simplify it down and compare your answer with the kid next to you. What do you get for your quadratic formula answer? And then factor this in. You look up in the directions, and the directions say, give your answer to 2 decimal places. Do you know how? X equals -5. It's supposed to be a negative b, right? Plus or minus square root of b squared, which is 25. See, that's b. Minus 4ac, 4 times 1 times 2, all over 2a, which is 2 times 1, because a right here is just 1. And that's, so it's all over 2. So it's -5 plus and minus the square root of, is that 17? All right, all over 2. So if I was doing this, I would take my calculator and I would find square root of 17 first. And I would round it to 2 decimal places. No, I would not. Why wouldn't you round it to 2 decimal places? You said to round it 2 decimal places because at the end you should round to 2 decimal places. I might give it 3 or 4 decimal places the first time I came to a part of the problem that had a decimal. Do you get the difference there? So don't round to the end. Now, sometimes it doesn't matter. Okay. -5 plus or minus. What is the square root of 17? 4.1231. Again, the reason I'm not rounding is because I'm not at the end of the problem. Now I do -5 plus that, all over 2. And then I would also do -5 minus that, all over 2. And those answers I would round to 2 decimal places. What is -5 plus 4.1231? What is that divided by 2? What is -5 minus 4.1231? What is that divided by 2? Now I got to round to 2 decimal places, -0.44 and -4.56. Is anybody thinking about something? Or did you forget? Is it possible that after all of that, you could plug it back in and it won't work? But you don't know that because I never told you. I just said solve this quadratic. But it's not likely it would just be a quadratic. It's likely that the problem would have started as a log, and let's say it started as this, or let's say it was base 3 of x plus 2. Let's say that was part of the problem. Do you get what I'm saying? And then there was more to the problem, and it ended up coming down to this. If I then have two answers and they're both negative, I would be looking close. Could I put both of those negatives into this? Well, actually, one of them would be okay. The negative 0.4, what was it, 0.44? That one would be all right, because this comes out positive still. But the negative 4.56, that one would not work. When you put that negative 4 point something in there, you have a negative argument. That one extraneous. Now that's not fair, because I didn't tell you that it was a log problem. So you didn't know that. But I hope, since it's happened to you twice already this hour, that we had two answers and then one of them didn't work, that you are at least a little paranoid. Check your answers. And this is also true, should follow through into next year into pre-calc. Be paranoid. A lot of times the answer is that one of the answers is extraneous, or the answer is that there is no solution. And if you would have checked your answer, you'd have realized that. All right. So I think you're in a pretty good spot. From here, it's now up to you to practice. So we have this big old review worksheet, but you got a big old amount of time, and I usually don't cut anything out of the reviews right before the test, because I'm paranoid that I'm going to have you skip one that would have really helped on the test, and then you're like, you told us not to do that one. So you should do all of them. In the end, if you can't, you just don't have the time to do all of them, I understand. You have a life, and yet this is the night before the test, so throw yourself into it. It is true that the cumulative is coming. So if you're like extra like scared, well, if you don't do so well, you will have to do corrections, which takes extra time. It's better to just do great job the first time. But the cumulative is coming next week. Okay? All right. That's all I got for you for the video for today.